Okay, so hello everyone. I hope all of you will be fine with good health, and I'm going to start the session. I'm going to share my screen right at the moment, and we are going to start with our session. Uh, Initially, I will start my own introduction. That who am I and what I'm doing currently right now. So my full name is Dr. Inam Ullah Khan, and I'm working as a senior IEEE member, also advisor at Cisco Community Pakistan. Apart from that, I'm having three major affiliation from abroad as well. I'm working with Indian one of a college as an adjunct faculty. Currently also working as a global mentor at IE School of Science and Technology, Spain. Also, I'm a visiting researcher at King's College London and a founder of AI Explain You Science. These are some of my affiliations I'm working currently right now. And over here, I'm currently working at New Tech, Zabest, Refa International, and all campus as well. So before going towards the session, I will try to talk a little bit about the introduction of the topic. The topic is purely about AI-driven critical infrastructure, deep learning, artificial intelligence, intrusion detection system, routing protocols, receive signal strength for Internet of Things, wireless sensor networks, and drones. So our topic will be wholly solely about these emerging technologies, and we'll be trying to cover all of these things with some case studies and with some real-time experimentations as well. Before going towards the topic and the rest of the outlines, I will try to say something about my collaborations. Currently, I'm in collaboration with King's College London. Also, I'm a direct collaborator with the University of Melbourne, IE School of Science and Technology, Spain as well. I'm working with them as well. I'm having some research projects going on with the Sejong University, South Korea, and also with the Edinburgh Napier University, UK. I'm affiliated. Apart from that, I will also include the Gachun University, South Korea, University of Calabria, Italy, Ibn Zahar University, Morocco, and another university from Marrakesh as well, and UPS is a university from India. University West Canada. It's also one of a prestigious university. I did so many collaborations with them as well, and currently some of my projects are going on with the University West Canada as well. In a previous year, I started collaboration with the University of Bolton, UK, and from last year I started my collaboration with the ESIEE Paris Institute. It's they are working on some emerging technologies, and in this year I started working with MMU with the Multimedia University as a collaborator as well. So these are some of my collaborations which I'm working with them keenly in some research projects and some sort of real-time projects which are about IoT, drones, and smart cities, and also about cybersecurity. Recently, one of a project of our is accepted in Dubai. It's also about cybersecurity. So many collaborations and projects I'm doing from rest of the world with the rest of the world. Some of my books are published. I will must talk about these books because they are having a major impact on the society and on the students and as well. One of my book, the first book of mine was published in that is about route optimization with ant colony in Germany, and you guys can see plenty other books as well on cybersecurity, on low powered wide area networks, One of a book is about even about Internet of Medical Things, big data analytics, and computational intelligence for cybersecurity. One of a book is about drones, and you guys can see one of the book about ethical artificial intelligence and power electronics. Also, purely the book is about one of a book is about cognitive machine intelligence, artificial intelligence, and even one of the book is about data science as well. So these are some of my books published, and these are also some of the recently published books, which is about unmanned aerial vehicles for protecting smart cities, AIoT in digital healthcare, artificial general intelligence, which is an emerging technological term. We'll see this term very soon after AI. And then there is one of a book about business transformation in the era of digital disruption. It is one of a collaborative project with the University West Canada. And also I did collaborated with the University West Canada about the tech startups and innovation in the age of AI. So all of these books are published either in Springer, either with Taylor and Francis, either with IGI. So I'm having some books publication with major and good publishers as well. And some of my books, which are currently even open for call as well, which include drones for future transportation, AGI based drones for climate change, and drones and artificial intelligence for future warfare. And one of a book is about robotics as well, AGIoT, and another book is about like the industrial transformation strategies for the digital innovation and AI adoption. So these books are even open for call for book chapters as well. You guys can do check these on internet, and you guys can easily submit the paper on the given email addresses and on the given EasyChair link as well. So these 5 books are currently open as well, and you guys can do, if someone is interested as a researcher, want to submit a book chapter, so they can do submit a book chapter. Our authorities, our entire team, the editors will try to check and evaluate the chapter, and then if it will be accepted, so then it will be published with these publishers. Moving towards some of my other publications like conference papers, journal papers. As a whole, to be very honest, these slides are a little bit old. I will say that currently, if you guys see my ResearchGate profile, so I'm having around 100 plus research articles. And yes, I'm having only one authored book, and the rest of the are edited books. So my citations you guys can also see, and the H index, which is highly valuable as well. And another link which I have given, that is about AI Explain You Science. You guys can do search me over there as well. So moving towards our topic, that is what is interaction basically. Currently at the moment, if I'm going to interact with a PC, with a laptop, with any non-living thing, so that also comes in the interaction. If I'm interacting with a robot as well, so that also comes in the interaction as well. We all are interacting in our daily life with so many devices and with so many things. So that's a big trouble as well. How to interact with these technological stuffs as well. So as a human, if we are going to interact with a machine, so what sort of interaction will be there? Like human robot interaction or either human machine interaction. It's a very trending topic, I will say, like human interaction. I will recall one of my own major topic. When I was in school, you guys can see the kid over there, and he's reading in the school. I will say like this is the exact replica of mine, because I was also a kind of student like studying in my school like that, and the teachers used to teach us like that. And my interaction with machine was I will say, terrible, and it was horrible. Why? Because guys can see in this slide as well over here that at our time when I was in school, I have faced so many things because I'm particularly from Khyber Pakhtunkhwa, and the place over there, it was like that drone attacks was happening in Pakistan, and Pakistan was having one of a joint venture with US, and because of that, in our school time, we always used to see so many people are having troubles with these machines. Like, to be very honest, in my mind, only this thing was coming in my mind that these are just a killing machine. They are killing people. So it was a big trouble for me. Like, I will say that my interaction with these machines was horrible because I saw these machines killing people and all. Might be it will be for our good as well, but in my mindset, it was just like that killing people and all. So my mind became like that. Even all the time we used to see in the news as well all the time, and we used to think that another drone attack happened in Pakistan, and it was a big trouble, and it was a big chaos with the people, and like with a mindset like me all the time studying and these things. So it was a terrible experience of mine with these robots and with these machines. So then I thought that let me do study a little bit, and might be it changed my mind regarding these trending technologies and all. So I thought to study well about these technological things. So I studied very much hard, and I did my level best to do achieve level in the technological things, to do apply these technological stuff in a good way, in a positive way. So I did my bachelor's in computer sciences, and then onward I did my master's in electronic engineering with a specialization in AI. And also I did my PhD in AI and drones. So my major was AI. And during my studies, during my PhD, I got a very prestigious fellowship about King's College London, which is a very reputable institute. You guys can see this particular institute as well, and it's a very prestigious university in UK. It's a top fifth ranked university in UK, and I was over there as a visiting researcher during my PhD, and it was a wonderful experience of mine during my PhD, and I did learn a lot of things about AI and drones. And I over there, basically, particularly in King's College London, I will say that changed my mind while meeting with researchers and scientists over there, and they was trying to innovate something. They was trying to work something towards for the good. I will say they was trying to use drones for good. They was trying to use drones for some sort of things like which should give benefit to the humans. So over there, my mindset was a bit changed regarding these machines, and then I thought that these machines can be utilized for goods as well. So over there, particularly in King's College London, basically I did work on algorithms basically. And over there in UK, in King's College London, as a visiting researcher, I was a cognitive algorithm developer basically. And I was working on some trending AI-based algorithms for drones, that drones should move in a way that should give benefit to the people. So I will ask this one particular question to all of you, that what is particularly algorithm if we are talking about algorithm. So what is algorithm? If we talk about algorithms, so algorithms I will say that set of instructions or either set of rules. So who this will come in your mind, that who invented algorithms. So like these step-by-step sequence was invented by a man called Muhammad ibn Musa al-Khwarizmi. He was known as the father of algebra and algorithms. He was a person, he basically invented algorithms. And right now, without algorithms, we cannot even do any work right now. I know that science and technology has emerged in a very better way, but currently, to be very honest, algorithms are everywhere. It is surrounded by us. And like world without algorithms is nothing, I will say. So it was a major breakthrough by a Muslim scientist, Muhammad ibn Musa al-Khwarizmi. And if we talk about protocols, so like these are also like the way we discussed, like algorithms are step by step, is a step by step sequence. So when we are going to communicate with each other, so like at the moment, currently I'm communicating with you guys in English. So English is a protocol in between me and you guys. So protocol can be any language, I will say. Like these are some set of rules for communication protocols. So if I talk about protocols, so protocols currently right now I'm communicating with you guys in English. If I'm going to communicate in any other language, so that language will be a protocol. Like the way if we are going to communicate through web services, let's say if I'm going to send an email to someone, so I'm also communicating in some protocols like SMTP, SNMP, simple network mail transfer protocol. Even if I'm going to send an email to someone, so for every particular website we are using HTTP and HTTPS, that we call it hypertext transfer protocol. So we are surrounded with algorithms and protocols. So at that time during my PhD, I came up with a new idea in front of my supervisor, and I said to my supervisor, like if we as a human are talking with each other, so why not drones should communicate with each other? So it was my idea that drones should also communicate with each other. So this was a basic idea of mine that if a human can communicate with each other, so why not drones should communicate with each other? So that was my, I will say, my idea that drones should communicate with each other. So as my mindset was also changed during my visiting researcher position at King's College London, and I thought that drones can be utilized in farming, drones can be utilized in medical supplies, saving lives, and either surveying, either rescuing people, either doing some pipe inspection somewhere, or either building structures, or might be someone is having a like a event or a function, so they can do film that entire activity as well. So I particularly thought in UK that drones can be utilized for goods as well. But over here in Pakistan, as I was a young kid and I was just thinking about drones, that these are just killing machine. But later on, my mindset get changed when I studied a lot about these things, and I got this prestigious opportunity as well. So I basically invented one of basically particularly made one of algorithm. This algorithm was particularly made by me, and I will say that it was a major breakthrough in drones as well, I will say. And I particularly modified IOT algorithm, and I did implemented my own mathematical formula, and I embedded that mathematical formula within IOT. And my mathematical formula was particularly about energy stabilization threshold. That particularly talk about like to conserve drones energy in a better way, like to update the regular pheromones. That is a common strategy in IOT. Like if I'm going to go through with the entire pseudocode of this algorithm, so like they will be checking the neighbors, they will be trying to check the pheromone updates and the values, and also they will be trying to check the next hop energy as well. And like over here you guys can see that when I'm talking about the LSF and the destination .pH value, so the pH is basically the pheromone value. So over here, I basically feed in the energy stabilization threshold, and after that, the similar process happen like the way it is happening in ant colony optimization or either in IOT. And the pheromone table is like continuously updating because we usually see so many parameters and feasible solution as well. This is some of a basic explanation of this algorithm, like how E-AntHocNet algorithm is working. So I am the inventor of this particular algorithm that I call it E-AntHocNet. I added E because of the energy stabilization threshold, and it was particularly to initialize some parameters to generate a feasible solution. And in the third step, like ants can do so many things. To be very honest, let me tell you the truth that ants are basically blind and they cannot see anything. If they are going to search something, so they will be trying to have a pheromone update. If through their mouth pheromone is coming out, like the way we as a human are having saliva in our mouth, and if that saliva will be coming out, so ants will be doing that sort of activity using pheromone. So ants cannot see anything, but they are searching food for themselves using pheromone. So pheromone evaporation can be done with the help of because like if the ants will be moving again and again on that particular trail or path, so then the evaporation will be done quite easily. Evaporation will be not done quite easily because like ants are moving again and again on that path. But if ants will be not moving again and again on that path, so then evaporation might happen over there. And then we'll check the concentration level. If the concentration level will be high, so then the ants will move on that path. Otherwise, the pheromone or the routing table will be updated accordingly. This was a mathematical formula which I invented. It was particularly about energy stabilization threshold. And the IE is basically initial nodes. Basically, I did implemented this on drones. So I was having around 30 drones and one base station. And so that particular purpose, I have utilized N for the total number of drones, I for the initial energy, E for the X dimension, that is the topological size, and B is the topological size in a Y dimension, C is a topological size in a Z dimension. So if I'm going to formulate this by putting the values, so initially I have put the initial energy, that is 75 joule. And as I told you that the number of nodes was 31. And for the X, Y, and Z dimension, because like drones usually move in 3 dimensions, so that's why I have given these values. And then after that, E is a natural log, and it is by default the value is 2.718. So after the calculation, you guys can easily see that 1/3 energy can be easily stored with the help of this mathematical formula. And over here, you guys can easily see that and E-AntHocNet have performed too much good in terms of packet drop rate. Like the packet drop rate was tremendous. I will say it was too much good in comparison with the other routing protocols like dynamic source routing, temporary ordered routing protocol like TORA, DSR, AntHocNet. AntHocNet is basically a traditional routing protocol, and I did change that entire algorithm, so that's why I have named that E-AntHocNet. And M is also a routing protocol. So in comparison with all of these routing protocols, our protocol E-AntHocNet performed very better results. In terms of throughput as well, we can easily see that E-AntHocNet performance is quite good in comparison with the others. Also, in terms of average end-to-end delay, we can easily see that the E-AntHocNet performed very well. So, in conclusion, if I say over here about this routing protocol, so basically, with the help of this energy stabilization threshold formula, the hello packets and will be exchanged quite easily, and they will update the neighbor tables as well. They will try to conserve drone energy, and they will also improve overall network lifetime, and it will be a big benefit to the quality of service as well. Like they will try to improve the quality of service or either experience. Also, apart from that, they will be trying to incorporation of remaining energy will also happen. Current energy level will be also evaluated. So these are the things before moving towards the receive signal strength using decision tree. Decision tree is basically a supervised learning technique. It's a machine learning technique. So in the earlier things I discussed with you guys about algorithm and a protocol. Right now, I'm going to move towards the AI things. Never think like that. That like the algorithm I have utilized that is an E-AntHocNet. It's an AI-based algorithm, which is a category of AI that we call it meta heuristic search algorithms. So I particularly worked on AI-based algorithms a lot during my experimentation, during my PhD. So I will say that receive signal strength is a very interesting phenomena. It can be utilized in UAVs. It can be utilized in IOT nodes. So decision tree is one of our algorithm that we call it a supervised learning mechanism. It's a supervised learning algorithm. Over here, you guys can easily see drone-attested vehicular networks. Like drones are connected with some smart city. In a smart city, you guys can see drones are connected with the vehicular vehicles as well. Like, and the vehicles are forming up vehicular networks. So it is working like that. So receive signal strength in flying ad hoc networks. The term for flying ad hoc network is like that. Like a flying ad hoc network is a combination of a base station, drones, and a satellite. So these three things combinedly give us flying ad hoc network. So these three things are interconnected with each other, and we call that flying ad hoc networks, which we call it FANETs. And receive signal strength is like that. If a drone is going to move far away from the base station, so the signal strength of the drones will be very much low. So this was a problem, and I thought to calculate this distance. Like if the drones are going far away from the base station, so what will be the distance? What will be the signal strength? So I thought to calculate the signal strength with the help of Euclidean formula. With the help of Euclidean formula, I calculated the signal strength, and by calculating this with a common example, I'm going to give an example about some trees we are having, like a forest, and the forest is basically connected with a base station. So let's say if the base station will be a little bit far from these trees, so we need to have a calculation of a Euclidean distance. So then we can easily send a message, either someone is going to cut the tree or something like that. So anything can happen. So that sensors on the trees will give a response to the base station that something bad activities is going to happen. So this can happen everywhere. So it's a basically wireless sensor nodes connected on trees, and we can say that we can calculate this with the help of RSSI. We call it receive signal strength. And I particularly did what? I implemented the similar formula on drones. Like receive signal strength is just like that. Like as the drones is going far away from the base station. So as you guys can see in the images as well, the drones are moving far away from the base station. So the signal strength is going to be weak. When the signal strength is going to be weak, so over here I basically applied decision tree approach. It's basically a very interesting approach. I will say it's a supervised learning approach. I already given the coordinates of the drones to the decision tree, and then the decision tree is giving me very good results in comparison with the other machine learning approaches like support vector machine or like random forest or any other technique. Because during my experimentation, I did experimentation a lot about the other machine learning or deep learning techniques, but decision tree was giving me very better results. And decision tree was a best possible approach to improve the signal strength in between the base station and the drone. So over here, you guys can easily see that with the help of decision tree, we did what? We did improved our calculations. We did improved our signal strength from the base station to drone. Over here, you guys can see one of the things, like if the signal strength will be strong, so then we'll be able to give a task to that particular drone. So over here, you guys see some drones. Let's say if the signal strength from the base station to the drones will be strong, so what will happen? The task will be assigned to that particular drone, and then people can be saved during the flood or something like that. So for that particular purpose, you guys can see that if there is a flood or any bad thing going on with that particular person, or if that drone is going to rescue that person, so they will be trying to calculate directly with the help of Euclidean formula, with the help of RSSI technique, and then they will be trying to check that which drone is too much near with that particular person. So then that person, that with that particular drone, that task will be allocated. So the exact same scenario will be implemented on the task allocation as well. So it's a very interesting idea that we can do utilize this idea on rescuing someone, because like so many things happen in Pakistan about floods. We commonly see so many problems in our country, particularly about like floods. Recently also in the northern areas, we have seen like floods was going on, and like it was a big disaster. Previously, we have seen some earthquakes. So like during earthquakes and these things as well, we can try to utilize AI-based drones over there particularly. So this is a very interesting idea. You guys can do work and research more and try to like in the first image, you guys can clearly see that the drone is basically assigned for that particular person. And right now in the second image, you guys can see that the person is going to be rescued with the help of this drone. And in the upcoming slides over here, you guys can see right now with the help of drone, that person is rescued properly, because might be anything can happen. So like task was allocated, it was just because of like allocating a task. So using RSSI through machine learning, we have easily assigned a task to drone. So these things you guys can do utilize that with the help of IoT, with the help of wireless sensor networks as well. So finding exact particular location of that person, we call that localization. So localization is what, like to find the actual location of this person. Like you guys can see in these images, drones was trying to find out the exact location of that person. So while finding out the location of that particular person, we try to use localization over there. Localization is a very interesting phenomenon. We call that, like, there are two types of localization. One is indoor and another one is outdoor or open air. So with the help of receive signal strength or either angle-based localization, we used to calculate the position and height of a drone or any particular machine. We used to calculate that. And then we try to calculate the distance with the help of RSSI using Euclidean distance. And then we can easily find out the actual and the location. Like over here, you guys can see that there are two UAVs. If you guys are going to calculate the two UAVs distance, so it can be easily calculated with the help of RSSI by calculating their distances. In this particular experimentation, I particularly used the ZigBee protocol. It's also a protocol. It's a wireless communication protocol. And normally there are around 14 or more variants of wireless communication protocol, like IEEE 802.11. There are many other like 802.12.3, like that. So ZigBee is a very powerful protocol and it's secure. Like people are right now working on ZigBee a lot because it's too much secure in comparison with the other traditional protocol. It's basically, it's a short range communication protocol where like drones and IoT and like wireless sensor networks, like over there, it can be easily utilized. And it's low cost as well, and it's easy to configure. And for the security, encryption keys, symmetric encryption keys are utilized, so it's very much secure as well. So if we compare this with the Bluetooth or like the other like IEEE 802.11 or other protocols, so it's too much good. It's long range in comparison with the other protocols. So Bluetooth and Zigbee comparison is like, I will say that Zigbee is too much good in comparison with Bluetooth. For the entire simulation environment, for the second experimentation, I particularly used MATLAB. For the first experimentation, I did utilize Network Simulator 2 for making a new novel routing protocol. Over here, I was working on receive signal strength. So over here, and I was working on basically on MATLAB to deploy decision tree on RSSI using unmanned aerial vehicles. So it was about my simulation environment. Even path loss exponent was like predefined, and the reference distance was also predefined. These were some of the results in the two-dimensional analysis. And over here, we can easily see the actual location and the estimated distance. So with the help of that, we can see that decision tree, with the help of decision tree, we have calculated the estimated and the actual location, and we have find out the localization quite easily. So around 9 drones was utilized in this experimentation, and it was an interesting experimentation. You guys can do this in a real time as well. Like some quadcopters, you guys can utilize that as well. Over here, I'm going to move towards one of our interesting phenomena, that is cybersecurity sort of a stuff. Like on drones, there are many attacks happening, like because like so many people used to send malicious connections and malicious data packets on drones. So I will say that sending malicious data to drones, it's a big trouble. It's a big trouble, and drones cannot do their like normal activities if someone is going to send some malicious content or like that. So sending spoof messages or like that comes in the category of malicious connectivity or like that. Like route request, either the connection is legitimate or not, either the connection is malicious, either the sender or like the source or destination, or there will be 3 things happening over there. So we call that malicious things as well. So in this particular activity, you guys are seeing the malicious connection. And denial of service is one of attack, that is a cybersecurity attack. We commonly call it third-party attack as well. Like there are 3 drones. They are basically, the drone is going to communicate with the base station, but the third one is basically drone, and that drone is that red drone. You guys see that is a malicious drone, and that malicious drone means like intruder. That we call it as an intruder, as an attacker. That attacker can be a human connected with a PC, and that PC is connected with a drone, through that drone they are sending some fake data packets, and they are trying to take the data from the other drone. So this is a basic example of denial of service. Over here in this particular slide, you guys can easily see the collision avoidance, like how because of the spoof messages, because of the attacker used to send lots of data packets, like DOS attack or DDoS attack or any sort of a spoof message they can send to the other nodes. So with the help of that spoof node can be easily hijacked, and collision avoidance can happen with the help of this cyber attack. Over here, you guys can see the concept of an intruder. Intruder is a person or either a drone. We can easily see the attacker. Over here, we can easily see the attacker, and the attacker is connected with this drone. So this drone is also an attacker. It's a victim, sorry, and this attacker is sending so many messages to this victim, and because of that their energy level is decreased, because they are sending lots of data packets, fake data packets. With the help of that, like DOS and DDoS attack can be happen. So because of that their energy level is going to be low down, and it's a big trouble with the drone battery conditions as well. So you guys can easily see in this particular figure that the other drone's energy level is high in comparison with the victim. So it's a basic concept of intruder. Intruder is basically an attacker. Intrusion detection system, I will give a basic idea of intrusion detection system. Like when we see these sort of attacks, so these sort of attacks can be identified with the help of IDS, that we call it intrusion detection system. There are around 6 to 7 or more types of intrusion detection system, but some of them are given below, like network-based IDS or host-based or either distributed data-based IDS or either signature anomaly or hybrid. So it can be deployed in IoT nodes as well, like collecting data from that particular node. Either that nodes are fake or either authorized or not authorized. They will be particularly connected with the ZigBee, like the way we discussed that it's a IEEE technology. And then they will be trying to detect some real sort of attacks with the help of IDS. So this is a basic framework of intrusion detection system, which you guys can see. You guys can see over here in this figure that drones are entering into a building or like that. So these swarm-based drones can be utilized in these sort of activities as well. Over here, I will just try to talk about that never fear about drones. It might be rebellious against humans, but fear about that drones who obey wrong humans. It's a very famous saying, and I will say that we must think about that drone should be in a safe hands, that it should be not with the wrong humans. So if it will be with the wrong humans, so these sort of things can happen. They can kill lots of people and like that. So these things can happen. So AI algorithms are even weaponized in the form of deepfakes as well. You guys can easily see that they used to change their images with the help of generative AI, and they can easily manipulate their faces. They can make new images with the help of deepfakes. And if someone can make a video of a politician and they try to send that video on social media sites and all, so it will be a big chaos in people that what that politician is saying and all. So deep fakes are right now quite in common and in trending. In conclusion, I will say that AI and algorithms are going to take over the entire world. So we should try to equip ourselves with the AI and algorithms. It will be too much good for us, and we need to work more towards AI and algorithms. And at the end, I will try to talk about the artificial AI Explain You Science. It's a platform built from my side, and I am the founder of this particular site as well, and this platform. I'm working on this platform as a founder, and I'm having some major projects about AI as well. And you guys can easily search it on the AIEYS.com as well. And also we are having the YouTube channel of the AI Explain You Science. We used to organize conferences, seminars, workshops, and these things. Also, we are having some AI-based projects as well. Currently, we are having plenty AI interns as well. So many thanks, and really thanks for the opportunity. I will say big thank and big thumbs up to the team of Corvit Systems. They given me the opportunity to talk in front of you guys and talk about AI, deep learning, machine learning. Even I did discuss about some cybersecurity stuff like intrusion detection system. Even I discussed about drones. I discussed about wireless technologies. Even I discussed about wireless communication. So I hope that you guys have found this entire session quite innovative, informative, and I hope that you guys have learned many things in this session. I think still we are having around 10 to 15 minutes, so I will move towards the question answer session. If there is any question, so you guys can do ask, and I will be happy. If there is any question, so you guys can do ask. If there is any question, I'm just here to answer that. Also, I will say that if someone is interested to contact me directly, so I will move towards the first slide. You guys can do contact me on my given email address over here. It's mentioned like Inam Ullah Khan 05 at IEEE.org. You guys can do connect with me with this email, and I'm going to answer some of the questions. I hope that okay. So some of the people, they are saying that the session is quite interesting, informative. Assalamu alaikum, wa alaikum assalam. Okay, thank you so much, Zahir, for attending this entire session. Sulaiman Tariq, wa alaikum assalam. Ahmed Saeed, wa alaikum assalam. I think there are no such questions from the audience. So I'm going to wind up with the session, and really happy to see you all over here attending this session. And you guys can do contact me directly on my email. And if you guys are interested towards the AI and some projects regarding AI, so feel free to contact me through my email. I will be happy to answer and collaborate with you guys. So really thank you so much for the time. I'm going to wind up with the session. Really thank you so much.